coming to you from Jezero Crater on the surface of Mars. This is Mr. C.
Well, 7th graders, happy downhill day to you. There's the hill. We've climbed the hill. We're going down the other side. Hey, I borrowed a hat from my grandson, Mario. Okay, and it matches my shirt. So anyway, you'll have to live with it. Tough it out. Okay, Mr. C wearing that dumb hat. So just live with it. Hey, I want to show you, there are just so many things I've got to do today. And I love this topic. It's one of my favorites. I do have a mystery guest today that right now is enshrouded in the towel. And you 7th graders, this will be on your test come Friday. Okay? So now I've got to grab this. I come down here and start taping, and my brains end up going everywhere else. So anyway, tonight you have a shot at the supermoon. It's a waning gibbous, so it's going to be not quite so supermoon, but still pretty super. And the reason is, here it is, the moon has an elliptical path around the Earth. So when it's here and here, it's closer to the Earth, and therefore appears, not really, but appears to be brighter because it's closer. It appears to be larger because it's closer. That's the reason, because it's got an elliptical orbit. All of that. My goodness, if it were me, I can just remember me sitting there in 7th grade. I would have stuck that in my journal so fast. It's on the test. And don't forget, you are going to be able to have a note card. So load up your note card. In fact, if you don't have a note card and you bomb, you're going to have to do a redo. You told us that already. You told us that but the last 2 days. I know. I'm just reminding you. I want you to do well. That's the whole point. So I want you to be successful. I want you to finish strongly, to wind up the year in 7th grade as good as you can do. So anyway, so all of that. Hey, you need a white sheet because I'm going to have you write down a few things. So you need a white sheet. And my nose is going bonkers. So anyway, can't help it. Sorry, can't help it. So now I love this topic. I love earthquakes. One of my favorite topics. And I hope you didn't have any nightmares last night. Because I told you that Arizona is a very stable part of the crust. Now, we do have some small earthquakes that can be felt in Phoenix. We've got some small ones. They're not big. So here is the moment magnitude scale. So we get once in a while a 5 earthquake to the north of us that can be felt in the northern part of the valley. So this is the moment magnitude scale. Now, I'm not going to ask you moment magnitude or MOMAG scale. It'll be a bonus point probably. So what is the name of the earthquake scale currently in use to measure how much energy is released when an earthquake occurs? How much energy is released? The moment magnitude scale. There it is. Now, as you move to your right on there, the earthquakes get larger and larger. 1 and 2 and 3 small, 4 or 5 medium, and then medium large. A 6, a 7 is kind of at the bottom end of the large scale, and the 8's a very large earthquake. A 9 is like a super large earthquake, and then 9 plus, really massive, okay, on the moment magnitude scale. Now, just want to remind you a number of things. Again, the supermoon is worth 5 points. I saw the supermoon. Now tell me the truth. Just get a parent's signature verifying that you actually looked at the supermoon. Get a parent signature on it. It's worth an easy 5 points. You've got the constellations available. Not for long though. Orion in the west, about 8:15 to 8:30, pointing to Sirius, the brightest star. It's on the test on Friday. Then you have overhead the Big Dipper. Big Dipper's overhead. The handle of the Big Dipper points to the east to Arcturus, the fourth brightest star. Sirius is number 1. And then the cup of the Big Dipper, those 2 stars at the outside of it point north to Polaris, which is above the North Pole. I'm going to ask you all of that on Friday. Now, over and over, I'm telling you what I'm going to ask you. You can use a note card, okay? And then, so I'm just showing you stuff I'm going to ask. There's the supermoon diagram. And at these 2 locations, here and then here, you can see in its elliptical orbit around the sun, its elliptical orbit, it's closer to the Earth. I said around the sun. I should have said Earth. I misspoke. In its flattened circle, elliptical orbit around the Earth, it's closer at 2 points. And that's when it looks bigger and brighter. Okay? And while I'm here, I want to show you this diagram. These will be on the test. There's Mr. C holding onto his hat. Oh no! Big earthquake. They do that in Japan. We don't have to. Okay? Anyway, you've got underground. It's got a U in it. Underground, that's how you're going to remember. The place underground where the rocks break. That's the focus. And then the place above ground, you can do this, Mr. C, right there, where the X is, that's the epicenter. You could just remember on the surface, it's the center. It's kind of the place where the energy gets centered. Focus underground, that's where the rock cracks, and it can go all the way up. And then the epicenter on the surface. Okay? So anyway, I'm going to ask you all of that. It'll be there. I'm going to ask you about proteins. What are proteins made of? 20 amino acids. I'm going to ask. I keep telling you. So proteins will be there. Are you going to put up the topics on RenWeb? I am. For tonight, they'll be there, the topics. So proteins made of amino acids. They couldn't happen by themselves. Your body is a protein body. It's made of tens of thousands of proteins and a few thousand at least different proteins. What do? All the jobs in your body. That's what proteins do. This will be a bonus point. What's the chance for one basic 150 amino acid protein forming by chance, randomly, accidentally, no one designing it? No chance. This will be a bonus point. 1 over 10. 1 over 10 to the 164th. That's a 1, you see it there, over the fraction, 164 zeros behind it. Folks, it's impossible. And of course, proteins were designed, they were made by God. Okay, I'm going to ask you about minerals. So I'm going to ask you the 3 kinds of rocks. Sedimentary, igneous. Example of an igneous: obsidian, granite. My guest is an example. Let's see, I'm trying to think of another one. Quartz, amethyst, igneous minerals, igneous rocks. Sedimentary, shale, limestone. Okay. Metamorphic, metamorphic. From one, changed by heat and pressure, to another. I'll ask you, heat and pressure. I'll ask you those two things. What are the two things that make metamorphic rocks? Meta, heat and pressure, morphic. Example, shale to slate. Okay. These are the ones you're going to need to know. So I would have your mineral sheet out, and I'm just going to point out which ones you're responsible for. Now, I already mentioned this. Shale, the mud rock, becoming slate. Shale to slate. Shale's a mud rock, a sedimentary rock. Slate's a metamorphic rock. Shale to slate. So you've got to know those two, that pair. You know I'm going to ask you this one. This is Obsidian. It's extremely hard. It's used for arrowheads by Native Americans. It's volcanic glass. Obsidian. Obviously igneous. When it hardens, so you've got to know that. There's 3 so far. And my favorite, of course, you've got to know it. Purple quartz, amethyst, and you've got to know this one. I think I've got it in here. Do I have it? Oh, where? Oh, there. Oh, there it is. One of my beautiful ordinary quartz crystals. See, look at that. Isn't that gorgeous? So ordinary quartz, igneous, right? So you've got to know that. So, and then you've got to know this. It's got rust on it, attracted by a magnet. A lot of iron in it. It's very dense. What is it? Magnetite. So far there's 6. I only get 6 more, maybe. So this one, the Continental Crust, is made of this. I want the best. Here it is. I want the best sample that I have of it. And here it is. A lot of this around campus. Granite, right? Granite. A lot of it on campus. Continental Crust. And then do I have... I don't have my sample, but I'm going to ask you anyway. What is oceanic crust made of? Basalt. It's made of basalt, so I'll ask you that. So that'll be 8. 2, 4, 6, yeah, 8. There's 8 so far. And then I'm going to have to limit myself. So I'll ask you this one, the writing mineral, and it's in here somewhere. I thought I just saw it. Did it disappear on me? So the writing mineral, there it is. The writing mineral. So I'll write on here. You can see that. I just wrote on here. The writing mineral comes from the Greek word grapho. What is it? Pencil lead, graphite. So there's 10. So I get 2 more. One of them is going to be my mystery guest. So what are you going to pick last? I mean, there's so many choices. So, okay. I will pick this one. So I'm going with this. Is it this one? Yeah, it's salty. Halite. You can kind of spell salt inside of the name. Halite. You can A-L, and you can take out the I, and then it's T, and put an S in there in the front. Salty halite. There's 11. And now my mystery guest. Come on in, mystery guest. Here it is. So you have to know this one too. This is so massive. Look at this one. It's just huge. Look at. Oh man. Oh, I dropped it. Actually, I didn't. I caught it. And it's very light, low density. And what is it? What is it? It's an igneous rock. It's got lots of little holes. where volcanic gases bubbled up through it. You could say boil, I guess. So what is it? It's pumice. So there's 12. So I told you what I'm going to have you do. So those are 12. So things that are on the test. Now I'm going to take, it's 15-minute mark. I'm going to take a little break. Let Mr. Phillip kind of help you out there with anything for a minute or two. And then I'm back with earthquakes. All right, here I am. So I am back, and I want to demonstrate a number of things. There's a reason that earthquakes don't happen in Arizona very often. So I just read something, that we haven't had a big earthquake in Arizona for, that was in the 6 range or more. I think over 100 years. There were some 6 earthquakes in the Flagstaff area, 1910, 1911, 1912-ish. There's a fault up there, but nothing big since then. So, 108 years ago, up in the Flag area. Prescott's got a fault zone, but no big ones from up in there. Recently, there's a fault zone under the Bradshaw Mountains. That might be the Prescott fault that I'm thinking of, that I've read about. And then there's a fault right on the Arizona border south of Douglas, Arizona. And in 1887, get this, I did not know this, there was a 7.6 earthquake. That's a big earthquake. I mean, that's a really big earthquake. And there were some fatalities. And there was hardly anybody living here then. So that was unusual. I didn't know that. Anyway, a 7.6. Wow. So anyway, so I'm going to show you this really quick. I'm going to ask this. Earthquake zones. Ring of fire, ring of fire, ring of fire. A lot of activity on the ring of fire these days. And then over here in the Atlantic, do it this way. There you go. In the middle of the Atlantic Ocean, the mid-ocean ridge. Big fault line. These are subduction zones, where one plate goes down under another. Subduction zones. And they cause the biggest earthquakes. They cause what are called mega thrust earthquakes. They happen like this. One plate goes down under another, and then sometimes this land plate does this. It thrusts up. And as it thrusts up like that, it under the ocean, it causes it thrusts up, and it pushes a huge volume of water toward the land. And that's called a huge tidal wave. We call it a tsunami. I think it's a Japanese word that means harbor wave, because it approaches the land from usually a harbor. So anyway, get it right, the 2011 earthquake in Japan, it was, get it right, 4th largest earthquake ever in the world. I think they readjusted it to a 9.1, a 9.1 on the moment magnitude scale. That's the biggest earthquake Japan's ever had. It caused a massive tsunami, which I think the video you saw yesterday showed something about that, and the video I'm going to show you today will show something about that as well. So now I want to do a little demonstration about how an earthquake happens. here's the way it happens. I've got to be really careful here. So let's say that the 50 centimeter mark on this meter stick, by the way, the metric system stuff will be on the test. So the meter stick is 100 centimeters, right? So that's about the halfway mark right there. So let's say from the 1 centimeter mark right here, can you see this? Can you see that I'm vibrating that? The 1 centimeter mark to the 50 centimeter mark is one plate. Let's say that's the ocean plate. And then the land plate is the 51 centimeter mark to the 100 centimeter mark, or the 1 meter mark. Here's what happens. Usually as the plates are moving, I'm going to ask you the 3 kinds of plate movement. What are they? There's sideways moving. You don't have to know the name, but that's translation. So sideways. So the tension builds up, builds up, builds up, builds up, and then it slips or breaks. The rock breaks. A lot of times it's just a little earthquake because there wasn't a lot of tension or pressure or stress that built up. But if the stress builds up for years, and then tens of years and hundreds of years, when it finally breaks, there's a lot of stress, and you get a bigger or really big earthquake. Sideways movement, then you know what this is called, convergent. They move toward each other. The plates come together and go up to form mountains, or one drops underneath, and then it's a subduction zone. And then the other kind of movement is apart. Divergent. Convergent, divergent. Convergent, together. Con means with, so like move with or together with each other. Convergent, mountains, or subduction zone. And then divergent, under the ocean, seafloor, spreading. Or, like in Africa, on the surface, on the land surface, above the water, you can get divergence as well. And that's the Rift Valley, the big diverging plate area in Africa. So there's actually a Christian school that's very famous where missionary kids have gone to, called Rift Valley Academy, because it's in the rift or divergent zone where the plates are moving apart. So anyway, those 3 kinds of plate movement. Then you've got your 3 kinds of waves. You have your first wave. What are they called? P waves. P waves because they're primary. So P waves, the first waves. Okay, very powerful. Okay, very powerful wave. Then you have S waves, the secondary waves. Okay, and then you have the last wave, the surface waves. The surface waves actually act like this. They go up and down. I think we experienced a surface wave earthquake when we were in Japan. And then other waves shake from side to side, and then some go up and down. So you get all 3 kinds of those movements in an earthquake. So anyway, so how are we doing time-wise? Pretty good. I want to make sure that I didn't leave anything out, and I've got to tell you about your homework. Pass your homework in that's due today. Name, date, period on it. Pass it in, please. It's worth full credit today. Full credit. Now I see just really quick that the P waves squeeze. So they squeeze plates together and then they move apart. So then the S waves move from side to side. You saw some of that. And then the surface waves roll. You know, on Friday I'm going to have you write Psalm 19:1. It's going to be worth 2 points. The heavens declare the glory of God. The sky above proclaims his handiwork. And then I'll ask you what it means. What does it mean? It means the creation glorifies God. I'll ask you about constellations and what they are. A couple of things you can do on Earth Day. So you can conserve water, and you can, in your own area, just pick up trash. At home in your yard or neighborhood, pick up trash. I have already said proteins. I'm going to ask you about the Mars helicopter. What's its job? To fly and take photos. What's Laura's big thing she wants you to remember this time around? Can do. You can do anything you put your mind to. You can do. If you practice, you'll get way better. Supermoon, the minerals we just went over. So anyway, all of that. Your homework is just to read page 128 and on a white sheet, maybe you could talk Mr. Phillip out of one. I'd like you to just write the 4 kinds of ways, several bullet facts each, that buildings can be made to withstand earthquakes. Now, they can't be totally earthquake proof, but they can be able to handle earthquakes like you saw, those buildings swaying, and you're going to see some more on the videos today, buildings swaying. So, in that biggest earthquake ever occurring in Japan in 2011. So 4 things that you can do with a big building to make it earthquake safe or seismic safe. So anyway, and that'll be homework tomorrow to hand in. That'll probably be worth another 5 points. So anyway, I'm going to turn you loose to Mr. Phillip. He's going to show you these 2 videos. So again, on one of my favorite topics, EQs, aka earthquakes. Test topics up on RenWeb along with this homework assignment. Mr. Phillip.